So let's look at multiplying polynomials. I'm going to look at a few practice problems. Remember that with math, we're always looking for the pattern. What is the pattern in question? In order to master this topic well, it's good to review your rules of exponents. Things like if you have the same base, you can add the powers if they're multiplying. And so we're going to talk about a few of the rules as they pertain to multiplying polynomials. And then please feel free to do more practice problems after you watch these videos. Or after you watch this video, but there will be multiple videos in this series. So let's go ahead and switch over to my notebook and we will do some practice problems. So now we're looking at some practice problems. We're going to switch to my notes here. And we're basically going to try a few problems from section 5 in Tyler Wallace. We start out with problems like number 2. Where you have a situation like this. So we can multiply using the distributive property, right? So the distributive property, so the 4k times 8k would become 32k squared, and then 4k times 4 will become 16k. So notice that when we distribute, we're doing the opposite of factoring, right? That's what we're doing when we're distributing. So we have 32k squared plus 16k. That would be our answer for no. So the main thing to remember is with the distributive property, multiply with the first term and multiply with this times this. So then you're just asking yourself, what is 4 times 8, right? And then you put the letters side by side. And what is 4 times 4, which is 16. So that's how we get the answer over here, 32k squared plus 16k. Number 4, we have 3n squared multiplying 6n plus 7. So we take 3n squared and we multiply by 6n. So 3n squared times 6n. And we take 3n squared again and we multiply by 7. So 3n squared times the 6n will give you 18n cubed. And 3n squared times 7 will give you 21n squared. You can add those two together. You have 18n cubed plus 21n squared. And that will be the answer to number 4. Number 6 would be, we have 3 going into 4r minus 7. So again, we're using the distributive property. We multiply the 3 times the 4, that's 12r, and the 3 times the 7 minus 21. So 12r minus 21 will be the answer to number 6. Let's look at number 8. What happens if you have a situation with binomials where you have 2x plus 1 and you have x minus 4? So 2x plus 1, x minus 4, basically the 2x times x, those two will multiply, and then you have 2x times negative 4, and then you have 1 times x, and 1 times negative 4. So what happened is each item, they call it, some people like to call it FOIL, even though there are reasons why FOIL is not, it's not a rule that you have to always do the first and then the outer and then inner and last. That's what FOIL stands for: first, outer, inner, and last. You can do them in any order. You can do the last first if you wanted, but yes, FOIL does work. And so you can say first terms. So let's use, so the first terms, and then you do the last, the outer terms. So this one and that one, and then the inner terms, this one and this one, and then the last terms, the 1 and the negative 4. So basically those all multiply out, and then we have 2x squared minus 8x, 1x here, and negative 4, right? So then imagine if we're going to add them together, we need to add like terms. So that becomes 2x squared minus 8x plus 1x minus 4. So that's 2x squared minus 7x minus 4. That will be the answer to number 8. So we use either the FOIL approach when we're dealing with binomials, or we use the distributive property. So this has given us a few examples to work with. The last example I'll give for now is number 10. For number 10, we have r plus 8. We have r plus 8. Give me 1 second here. So if you have r plus 8 and then 4r plus 8, so we take the first two terms, r times 4r, that will be 4r squared. And then we take the outer terms, so r times 8, right? R times 8, which would just be 8r. And then we have this times this, which is 4r times 8. And that becomes 4r times 8, so 32r. 4. Remember, like terms are variables or letters in the same power. So they have to be the same letters because they both have r. So 4r squared plus 40r plus 64. So we have our final answer as 4r squared plus 40r plus 64. The other way that we could write this answer, because they all share a 4, is you could take out a 4 and have r squared plus 10r plus 16. So r squared plus 10r plus 16. But you could just leave your answer as 4r squared plus 40r plus 64 in this context, because the point was to sort of multiply it out. But yes, we can factor that back in, and that will be the answer to that particular question. If you have any other questions, let me know. This is practice for 5.5 from Tyler Wallace. Thank you.